So out of you, I just want to make sure I target this right. Who knows anything about functional programming? Cool, okay. Who actually types some functional programming once in a while? Cool, and who does it all the time? Okay, just checking, hey, you know. So what we're gonna do today is actually, I'm gonna tell you how we used F# in Onikira, the game I'm working on. So that's a thing. It's at the moment, Onikira is on early access on Steam, and since November, and it's doing pretty well, I think. So that means we can ship some code in F#. Actually, if you go and get the game on Steam, you can see f#.core.dll there, which you know, it's like proof, yay! So yeah, Onikira, that's it. So you know, most of the times when you start telling people I'm doing games, I like F#, they kind of go like, wait a minute, this is kind of crazy. Why did you want to try functional programming, right? I mean, it's like, it sounds kind of crazy or maybe new. Functional programming is not a new paradigm. It's something that's been going on for way before object-oriented programming, by the way. But anyway, that's not the point. The point of this is that I was trying to find a way to fight complexity, to make my code easier to understand so that I would make less mistakes, so that there is less bugs, because nobody likes bugs. I mean, any of you like bugs? Maybe Leszek, because he likes fixing bugs. He loving of bugs, but we want to do something like, ideally, we want to write the code once, right? So I was thinking, okay, how do we get this to be better? And then I had one of those, you know, one of those times that you remember that something happened. It's like that time when you hit, you know, Darwin with the apple, or hopefully it wasn't that momentous. I just, you know, got to find this paper, right? And this paper is called Out of the Tar Pit by Mosley and Marks. It's a paper from 2006. Do you read papers? Good, that's the answer. If you don't, start reading papers. Blogs are cool, books are cool, but most of the truth are in papers because people need to prove stuff and whatever. They tend to have all the meat of the knowledge. Anyway, this paper talks about what causes complexity in software. Oh, cool. Oh, nice. Now it's a proper conference, right? So we were talking about complexity causes. And in this paper by Mosley and Marks, I don't know if Mosley is the right way to pronounce it, but you'll forgive me, right? So in this paper, they proposed that complexity is not caused by the inherent problem. You know, it's like, oh, it's a difficult problem, tough luck. There are difficult problems, but actually, most of the complexity, we cause it ourselves. We are developers, so we self-inflict this pain, right? Are any of you familiar with dependency injection? Okay, so that's one of the patterns that is like, we probably could deal without it sometimes. You know, it's like unnecessarily complex, I think. So maybe in game programming, singletons. You know, an idea that a lot of people go around and go like, oh, why is this? You know, we should use a singleton. And then you go like, no, this is a problem, why? And people start going around in circles. When you start going around in circles, like I imagine people thinking about singletons like they have a stick and they go like this. Because they forget what the problem actually is. So anyway, they were talking about the complexity causes. One of them is state. So what that means is that you wrote something and it has a property. So let's say we have a class, and a class called animals. And then you have a property called name, right? And the property has a getter and a setter. And if you have a function somewhere else that has an instance of an animal and that changes that name, you don't know. You don't know what you don't know what the name actually is. You don't know if something else said it. You have no guarantees about that. because it's mutable, right? So you have the simplest, this is one of the simplest of simplest things you can have, right? You have just a class with a property, and already you have a potential source for millions of bugs because you have no idea what's there. No guarantees. How many bugs have you found that way? I found many that way. How about nulls? Anybody had a null reference exception ever? Any people you can start crying now? Okay, cool, that's good. We'll go to the psychological evaluation sessions later to cry together. So we're talking about state. Okay, so state is definitely a source of problems, right? Then flow of control. This is about how you can create bugs for yourself by changing the way things run. How many bugs have you found in your own code that you wrote? You know, not even your friend's code or that idiot that works with you. God damn it, Joe. I don't know any Joe, so that's okay. And that because instead of running the adding sum function and then running the add after sum, but actually should have run before, you know, badly named maybe, you have a bug. You know, something that you didn't expect to happen, happened. The name of your animal, instead of being monkey, is monkeys, and suddenly your equality comparison is all over the shop. Oh, So, okay, we have state. This is all bugs that you all agreed that this is true. Flow of control, this is the order in which we run things. And then we have code volume, right? If you have to look after a source, a body of code that is like, say, I wanted to say millions of lines, but let's just say 5,000 lines of code. Do you remember 5,000 lines of code in your head right now? Anybody? I'm gonna say no. In fact, the human brain can keep up to 7 things in one's kind of current state, +2, -2. So unless you're very, very special, you also can't remember 5,000 lines of code. So basically, that drives us to being this cat. A cat that is like, ah! Because this is how we have to deal with software, right? Anyway, this was the paper. And they proposed that, they said that basically writing simple code is really, really hard. I don't know if this happened to you, but sometimes I read code, and if you don't read code often, please start doing it. Just grab any code from anywhere and start reading it. Finding code that you just read and go like, I think this is exactly what it does, and it's clear, and there's no noise about it. It's actually rare to find. I like reading sometimes for game code. I like reading Carmack. You know, he published a lot of open source code. So, you know, that's a good source. So, but Carmack is a bit of a genius, right? So, writing code like him is kind of hard. Anything like this sound strange to you? Do you agree? Do you disagree? Anyway, I'll take the silence as yes. You agree and you are all happy with what I'm saying. Good. So anyway, in this paper, they described this as the sources of complexity, and then not only they said, okay, this is complexity, they also said, these are some solutions. And they proposed that functional programming helps you with these sources of problems. Basically, they said that on the functional side of things, everything you get out of immutability by default and functional high-order functions, that would be that you can pass functions as parameters of functions and give you a lot of bang for your buck. That's the short version. If you want to know more about it, you know, you can do this thing where you grab your internet and you go and get the paper. It's open. You can read it. I will highly recommend you do that. So anyway, I'm going to let you read that because it's boring when someone reads on top of like a lot of text, and I assume you can all read. Right? Good. Did you read that? Okay. Boop, 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 beep. Okay, so I'm going to assume you read that. Who do you think said that? And any haphazard guess? like wild guesses. And we're in a games kind of related conference, so that's a hint. Any hint? Anybody maybe? I'm gonna point at someone and you're gonna have to guess something, so you better start guessing soon. Let's see, what do you who do you think said that? Just guess, it doesn't matter. God, okay. I'm gonna say, I listen God, so I'm gonna go with that. How about you? Any guesses? Maybe Carmack, that's a good guess. Actually, one of the founders of Naughty Dog, they use Lisp for their first two games, which I kind of don't remember the name. So, hey, we're talking about real games made by real people. This guy actually studied at an MIT. So, this is Lisp and C, all happy together in one family of games. So, when you get Carmack and Naughty Dog co-founder telling you, hey, you know what, it's doable in games, hey, why shouldn't I try, right? So, we tried F#, right? F# is a functional first language, which means a bunch of things, but the two things that I kind of think the highest is that you have higher order functions and immutability by default. It's a programming language created by Microsoft, Don Syme in particular, but at the moment is maintained and by the F# Software Foundation, and for the last version there was over 100 commits by people completely outside of Microsoft. The .NET interop, so basically working with C# and F#, using it in Unity or in any other game engine is totally cool. It has a really strong type system. If you work with C# only, or C, C++, your type system it's kind of, on its strength, is like there, and F# and Haskell. F# is here, Haskell is here. I know that sounds like I'm trying to diss it, but I'm actually trying to explain from a type systems literature about what you can do with it. And it's really hard to explain with concrete examples, because I would have to give you like hundreds of examples, but you will have to go and check it out and see what I mean by it. Basically, what you feel as a developer is that the compiler tells you, nope, 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 but when the thing compiles, it probably works, and it probably has no bugs, and that's kind of cool. So, as I said, F# is open source, and for the last 2 years, it's also cross-platform. That means that it runs on everything. I was doing a workshop on Vienna on Friday, and a guy got running on Emacs, on Linux, on Ubuntu, some more crazy distribution. So that's good. I know it works super well on Macs. You can use Xamarin Studio. Again, questions are super welcome, because I feel like I'm talking to like people are like, are you interested in this or not? I don't know. So, and it has a really good learning curve. So the way I got into functional programming is that I started off with Haskell. And Haskell is a super hard language to learn, at least for me and other newbies. Particularly if you've done any other object-oriented programming, you'll find that you need to totally rewire your brain, which is cool. But when you do F#, I think you can start off doing dirty stuff. So dirty, I mean imperative and object-oriented. And then it's like the language drives you to try to be cleaner. And when you're not, it kind of tells you, hey, you are doing all horrible things and you should change that. So yeah, what does it look like? I'm sure we're all developers here. Yes? I'm trying to get you to wake up, really. It's like, cool. So this is what it looks like. Can you see over there? I'm going to hope that you do. If you don't, there is like loads of seats up the front, and I can embarrass you better. So in here, okay, so in here we have, oh yeah, actually, I'm using FS reveals, and remember I was telling you how F# type system is much stronger. Not only that, you can also get like type information in a kind of concise and nice way on the slides, but which I kind of like to show off. But so anyway, in here we have a list comprehension. If you've never seen one, basically what's happening here is you're creating a list that goes from 1 to 100. Then we're using a function composition kind of operator, and we're saying the result of this, we want to put it here, in here. So we're saying we're going to sum everything that's in that array. You could have some other array. And then we're going to print it, right? And what we're saying here is, again, we're using this function composition thing again, and we're saying the result of all of this, we're going to put it here, right? That's pretty cool. Now imagine that in whatever language you use most of the days, which I'm going to imagine is not F#. Now, how many lines of code versus how many lines of code? What can you get wrong here, right? What things can you screw up? And this is where you start getting little bits of win, right? So in here, we're doing the square of a number. This, by default, actually, I'm going to show you this. So the language will infer that x is an int. I could annotate this to be a generic. Also, I could say it's any number. I could say this is only floats. And again, we're getting kind of more bang for your buck for the type from the type system. Then we're having something like square 42, and this will be a value. So we can use the functions immediately. So in here, then we have a record, and that would be an equivalent of doing a type definition. So you're gonna, in C#, the equivalent of this will be public class person, getter setter, sorry, getter for the first name, getter for last name. The setter will be private, and you have to put it the parameters in the constructor, because this is read-only by default. And the other good thing is that this is a record, so you get like structure equality. So you can actually, if you have person, if you define a person, and then you define like B1, and then you have another person, B2. Let's say one is Andrea and the other one is Andrew. When you try to compare those two, it will work. It will try to compare and see if they are exactly the same values, and if they are, it's going to return true. Something that you will need to implement yourself in most of our languages. I don't really know if it does that in C++. So another really, really cool thing is you can have these types. This is a discriminated union, and you're saying here that an employee can be a worker or a manager. And the manager is kind of, you're saying that the manager can manage all these employees that are of this type. So it's kind of like a combination of hierarchy and like a subtype, but also similar to an enum, right? If you've never seen this, it's going to be like, what? But if you start using it, you'll realize it's really, really strong. Good, that was the reaction. The good thing about this is that you can pattern match on this. And we're going to see some examples of pattern matching in like 2 seconds. But as you can see, very little, very concise code. And you can do a lot. And that's pretty cool, I think. A lot of really good, a really good source for F# knowledge is a website called F# for Fun and Profit. Go there, read stuff. It's written in a really nice and kind of idiot-proof way. I don't know if that's the right way to say it, but. So, you might want to, okay, that's a nice language. What do we use it for? So we use it for 3 things in general, and we're going to go through them. So we use it for scripting, we use it for testing, and we use it for build script. So we're going to see pattern matching. So what is pattern matching, right? So this is no regex, nothing to do with regex. This basically is trying to do some sort of matching with a data shape. So this is data, and this is the shape. In this case, it's a number. So if we do this thing where, see, we're saying, oh, that's an int, cool. And this is that's cool. So in here, we're saying this value, an expression is a value, takes an int and returns an int. So this is function definitions with strong types, right? So in here, this signature becomes really important. Instead of thinking of classes, you think of type signatures. So pattern matching, we're saying, I'm actually pretty sure you can guess what's going on here. Anybody care to guess so we all wake up and I stop talking all the time? I'm gonna point at someone and you won't like it, so guesses are good. Save your error, people. Come on, you can do it. What's going on here? What's happening here? If n is 0, what happens? Good, yeah, so we all know. So if n is 1, oh, what happens in any other case? Cool. So now I didn't bring him. He's not like my friend. I don't know that guy. Okay. So we're actually saying this is a recursive function, which when this is actually how you stop the function probably, and we're saying we're going to call Fibonacci on any case that is not 0, 1, with n minus 1 plus Fibonacci n minus 2. So this is like different function calls. You can imagine that say we had 3, we're going to do 3. Is it 0? No. Is it 1? No. It's 3. Okay. So n minus 1 is 3 minus 1 is 2 plus, and you calculate that, you imagine that is going off, running somewhere, and then we do plus 3 minus 2, it's going to be 1, it's going to come here, and blah, blah, blah. You can follow this, right? I'm just trying to, everybody follows? Good, okay. Is it difficult? No, it's simple. Good. So we just learned pattern matching and recursive functions. Awesome. Now, this is an example from our game. I had to kind of make it slightly simpler so it fits on a slide. Actually, so I could fit 2 examples in a slide. Cool. So in here, we use a game engine called Duality. It's an open source C# game engine. It's very similar to Unity, except that it's open source. And it has an editor and everything, and you can extend it, and it's good. So in here we're in a kind of, we're inheriting from a component, and we have our own kind of script, and we have access to the parent game object. I'm going to show you, but it will make slightly more sense. If you've never seen a component, if you've never seen Unity, this might be slightly strange. If you've seen it before, it's probably really simple. So in here we're trying to define a function called unlockAchievement. We're passing a game object and an achievement. So here we're saying, if you find a character controller, do something. That's kind of what this does. So in here we can find a null. Remember how I told you F# doesn't, you don't need to deal with nulls. However, we're interacting with a C# game engine that does actually allow for nulls. F# interrupts really well with that, so we can still check that this is null or not. And we're saying, if it's null, do nothing. That means I didn't find a character controller in that game object. But if you did find one, and it's on the ground, then I'm gonna use an unlocking of achievement, and then I'm gonna dispose. I'm gonna do this dispose later so that I don't have any array problems. So in here we did that. Is that clear? Cool. Any questions? Okay, now this one is for you. This is a nice test for you. So this is like I'm getting a message in here, right? And I'm trying to do something. What do you think this is? Remember how we're saying that we're pattern matching and we're matching the data shape. And I'm kind of slightly tricking you here to see how is it for you, right? So what do you think that means? We're saying the message, this is a type. Actor died message is a type. Exactly. And we're doing, not only we're checking, we're saying if this is the type, so this is type checking, and it's saying that message become died message, just because I want to call it something different. It's actually, you're not casting, you're just checking if it's exactly, casting would be that you change the type, where in this case you're saying, is it exactly that type? So in here afterwards you do the unlock achievement, so we defined that before, that message game object, because the message has access to the game object, and we're saying, you're killing in the air. So again, very, very small code that does a lot of things. Concise, and I hope clear, because you were basically guessing, and the guess was correct. Active patterns. So active patterns is a really kind of cool feature of F#. Is everybody on board here, or am I going too fast, too slow? Too fast. Perfect. Okay, cool. So active patterns is a quite advanced feature of F#. In a way, it's quite simple. So far in patterns, we've seen really, really simple things like message. This is just seeing, this will be reduced to a value. But sometimes we need to do more complex things. And what active patterns allows you to do is kind of create reusable functions that decompose the input and allow you to kind of abstract the idea of what you're trying to do. So examples are great here. We use these banana clips. See the way they look like bananas? It's awesome. So in here, we're saying, this is the pattern matching that we need. So in here, we're saying, oh, the keyboard will do something. So this is kind of cool, right? When you're using this match and saying space key is true and hold 100 milliseconds false, you do something. And if you have the space key true and hold 100 milliseconds true, so you're saying, I want these functions to be false and true in each of these cases. So when you're doing this match, it's kind of checking, what is this space key thing? And it's going to go back here and run this. And then when you're doing the hold 100 milliseconds, it's going to go here and check. Pretty cool, eh? Now, you're not doing anything crazy about, oh, this thing is going to somehow define saying this is how you should use it. No, it just, the compiler knows that you're talking about this because you're within a pattern matching construct. And that's really, really useful. Obviously, you can do even crazier things. You could, I think I have a better example even. Oh yeah, so that's a single case pattern matching. You can do a multi-case. So we do again this on update, we have the keyboard. So similar thing, you're just passing the information here, which is a keyboard input. That actually goes all the way to OpenTK, and it's quite fun and whatever. So in here we're saying that we're defining 3 potential kind of matching values, and we're saying if left key, well, you do something, or vice or vice. But in here, you respond with this left key value, right? So the way you read this is like here, left key, left key, left key. So you're saying, given a different set of conditions, you're going to respond with, okay, this is the case that you're saying that is happening. Does that make sense? I know it's kind of hard to, when you're trying to write this, the first few times it's like, wait a minute. But once you start doing a few exercises, and then you realize, oh, okay, that's how it happens. So again, very, very useful for slightly more complex switch flag statements. But sorry, actually, these are not enums. Yes, yeah, you can think of it that way. So that's pattern matching. So we've seen beginning the language, we've seen recursive functions, we've seen active pattern matching and active patterns. And that's in less than a half an hour, so I think we're doing well. So, you might be thinking, okay, F#, this weird language, does it even work? Because, it's a normal concern. F# has been developed over the last 12 years, so, not a new kid on the block. But then you might be wondering, okay, how do you consume C# code? How do you consume what it says there? because otherwise I will say it, I always say it the other way around. So in this case, we're using F#. So we wrote some F#. Here it's a calculator, it's really good. I know that you know how to write a calculator, so I'm gonna assume that you know how to do this rest of things. So in here we have namespace calculator, module calc, okay? And then I'm gonna have a function called add that's gonna take numbers and a delimiter. Right, so in here, we're using it from C#. I put the C# on top because I assumed some people on the back would be like, what? I can't see. But you can guess more or less what the F# looks like. All we need to do is, say you have two projects. So you all use Visual Studio, I assume, or know how it works? Okay. So you will have a solution, and then a project that contains F# and a project that contains C#. And you have to reference the F# project from the C# project to be able to use this. Once you do that, you can just literally call it. So this calculator refers to this namespace. This calc refers to the module. And the add function is the add function that we defined here, the numbers and the delimiter. So I assume it gets us a value, and then we write it. That's using it. It's like as hard as that. There is no magic. You can think, oh, maybe no. In our languages that are running on the same virtual machine, the interop is not as fluid. When you're using C# from F#, you can just do basically the same. It's actually probably easier. This is an example of a test. I don't know if you use an unit or not. It's a quite common unit testing framework. So all you have to do is do this. If you were doing this in C#, you will have the test attribute anyway, and will have the function definition. Please note, this is another function of F#. You can do double quotes, and you can actually write text. So you have, the test results generally run in a report, and you can see the names of the test in actual text as opposed to camel case or some other crazy stuff that we've done for a very long time. So that's very cool. Basically, interrupt just works. There is a few edge cases where you have to do, for example, you shouldn't expose features of F# that are not available to C# at all, such as DUs or type providers, which is something that I haven't mentioned yet, so they are slightly more advanced. On the REPL, oh yeah, one of the cool things about, I'm going to escape this. Things like coding in here is actually quite, no, please? Okay. Or no. Okay, I'm going to just keep going. The REPL is just basically, you have a console where you can run F#, and haha, I got you. And you can just basically run code. So you can type let C equals 5, whatever, and it just runs. Like in there, you can also add, say for example, I'm working with this code, I can add the references to whatever I'm working and run it here. So you have a very, very rapid feedback loop, which is something that C# actually does have, but not a lot of people use. So at the moment, we're using the REPL for exploration. Sometimes we have questions like, oh, does this work this way? And you can actually go and check it with running code as opposed to, I think that, which is good. I'm hoping that we can do live coding. The guys, if you're interested in this, the guys from Arcadia, they are doing a project called Arcadia. They use Unity and they put Closure on top. Closure is a Lisp, right? And you can basically have Unity running and do crazy Lisp stuff, which is very, very powerful. I highly recommend you try it. So you might be, okay, we look at the language. Now let's look at the ecosystem. Like, what tools do we use that are so cool? The first thing we tried that I really, really liked was property testing. So, see, property, I don't know, how many of you write the unit test or integration tests? Not a lot of people. Cool. So why don't you? Well, in game code, writing tests is really, really hard because stuff changes just way too often. But wouldn't it be cool to have tests for really, really core things? Wouldn't it be better even if we didn't have to write all the tests? We could just generate them? Yes, okay, cool. See, I was trying to check if you were awake. It seems like you're not awake. So what you do is instead of kind of writing the test, you kind of think of properties of your system, such as, what is a property, you know? We're saying that these two things are the same. Wow, they finished early. We're saying that when you add two things, it's the same as when you multiply that thing by 2, right? That's a property. We're saying that if the reverse of a list is the same as the original list. So you think of your system in terms of what it does as opposed to thinking of concrete cases and how it behaves. So again, fscheck, where does it come from? This is a thing that comes from Haskell. There is a really good article that you can read about it. These slides will be available as soon as we finish this, in case you want to see them. So basically, a long history there that you can rely on. The good thing about it also is that fscheck is a very small library that you can just use. You don't have to install some crazy framework or whatever. So here we have that example of the property in fscheck, actual code that runs if you want to. And here we're saying x plus x equals 2x. And the way it works is that fscheck will generate whatever you pass as a parameter there. So here you pass any int. We're saying, I need an int here. Generate randomly a bunch of ints, and get me the result. And that's pretty cool. So you can use it in a very naive way, in the same way we use it here. For example, health systems, right, in a game. You can do very strange things to your health systems, right? Maybe you did some crazy bonus points or crazy thing that, you know, when the boss shows up, all your health goes to 0, whatever crazy rules you might have. What you do want to know, one property of my health system is that I never want it to be higher than max. No matter what stuff happens here, I want that never to happen. So I'm saying, hey, fscheck, can you please give me a max health? That would be my generated max health, and an actual increment that I could change. So in here, we're just initialization. This is the part that matters. We're saying health component, which is the component, max health, will always be bigger than or equals to the current health. That's actually health, but you can't read it because reasons. In here, I have this precondition that max health has to be bigger than 0. This is an operator that I created so that I can verify that too. So those are actually two things that I want to know about my system. Again, the important thing that you can take away, you can read this code later at your own leisure, is that you can define a property of your system in a very short way. Think about this as initialization, so it's whatever. And this is very short. And it gives you the security of you're not doing some crazy stuff with your health system, which is good. And here I'm checking that thing up here actually holds. So my tools are actually showing me that I'm not crazy, which is good, because I need to know that. I mean, don't you need to know that you're not crazy? Good. So we're going to go fast because we're getting late. So fake. How many of you have bash scripts for building your stuff? And you love writing them, don't you? Yes, I can see the love is totally there. So fake, you can write your build scripts with a really strong type system. So imagine instead of writing strings everywhere, you have types telling you how you're screwing up before actually running your build scripts. So how does it look? It looks a lot like MS Build targets, but strongly typed. Like all of this stuff is typed. So what I'm going to do here is this. Actually go and show you an example. So what we have here is one of our plugins. I know you can't see the plugin, but I am going to run the build script while I tell you what's happening. So that's going to stay there for a while. Meanwhile, I'm going to open this in Sublime and show you. Nope, don't do that. So, okay. So in here, tell me when you don't understand what's going on. Here we have a few directories. We define a version, and we say, please clean the directories. Then here I say some properties that is going to be written for packaging. Here I'm saying compile and save, so I'm going to use MS Build to go and actually make the project be unsafe because I'm interacting with C++ or C, one of them. Then I run my unit tests. I create my NuGet packages. That's how we deal with dependencies in .NET. And then I can run the different targets at different ways. So in here, I just have this. But say I just want to build a NuGet package because that's what I'm working on. It's cool. You can do it. This works for MS Build. I'm pretty sure that if you wanted to, you could use it for something else because at the end, you're generating that code. So very, very cool. And we're using it in a lot of stuff. So that's good. And finally, compiler services. We use this for gameplay. And I'm going to show you now. This is Duality, the game engine I was telling you about. And we're going to, this is some code for running a spline. So we're going to open a scene called Digital Dragons. Whenever you're ready. And this is the script, right? So in here we have these properties. They are not very functional, but whatever. And we're running this update method. We're calculating a t, and then we're going to change the position using the spline component. So once this opens, it's generally not that slow, but it's because we're demoing that it takes more time, right? So in here we have a game object called spline component, and this is there. We're on a spline editor. I know that you can't read that, but there's a few versions of that. And then we have another game object that has a sprite renderer and a script component. In the script component, we can see some properties that we defined. So here, see the way it says spline component and duration. These are properties we defined here. Spline component, duration in seconds. Cool, eh? So if I change this to add something else, it would change. The editor would change along with it. So I'll just run the demo. And it's working. Yay! That's pretty cool. And with like 3 lines of code. Like this is the actual code. That's kind of cool, I think. And the good thing about it, say I do this, right? And say this. Log. I just want to change something so you see why this is cool. Right? Save that. I'll stop it. Come on. And I'll play it again. So I just saved my script. And it's writing here. I don't know if you see, I typed DTDDD. Now it's updating. So I just need to save. I don't need to recompile. I don't need to do anything crazy. It just works. And I think that's pretty cool. I don't know how many of you wait about 10 minutes to make something actually visible on screen. I heard some pain like that. Anyway, so I think that is very, very powerful. We actually can do the same with C#. So, yeah. Resources. I'm sure now you all want to go and learn F#. These are some resources, F# for Fun and Profit, fsharp.org. If you want to get your hands dirty, F# cones or F# tutorials. And that's all from me. Thank you. Any questions? I think we have like 2 questions. No? Yes? Oh, okay. We have loads of questions. Yes? You want to do this? I'll repeat the question.
So I wanted to know, could you maybe show us what debugging of such code looks like?
Okay.
Can you like do breakpoints on, what's the workflow for it?
Actually, you can debug the same as F sharp, as C sharp, exactly the same. I think I actually broke debugging on this version of the scripting, but debugging does work. We've been, yeah, but for F sharp, just normal F sharp, you can, it's exactly the same. There's no difference. You just debug. Any other question? That's it? Are you sure? Cool. You look questionable. Oh, okay. Well, thank you so much. I hope this was entertaining, and if I'll be around if you want to chat a bit longer. Cheers.